Welcome to Maritime Matters, a podcast focused on leaders in the maritime market, the people, the companies, the technologies that are making and breaking the news, helping to lead the maritime industry to a safer, more efficient, more profitable, and cleaner future. Welcome aboard.
This is Greg Trautwein with Maritime Matters, the Marine Link podcast. And we're very pleased to be joined today by Jim Carr from Seaspan ULC and Philip Lewis, the Director of Research, Intelatus, to discuss one of the most exciting projects in recent U.S. maritime memory, the quest to rebuild the U.S. Coast Guard Icebreaker fleet. Can you provide a brief career background with an overview of your responsibilities at your respective organizations today?
My name is Jim Carr. I'm the Senior Vice President of Engineering at Seaspan Shipyards in Vancouver, Canada. I'm a 40-year veteran of ship designs. I grew up in Bath, Maine at Bath Iron Works, spent a good portion of my career there. I was their advanced design person, and with that job came a lot of opportunity to design lead ships. I was part of the Arleigh Burke program. I managed the Flight 2A upgrade in the early 90s, and then I went on to design the LPD-17. I was one of the design managers for the LPD-17. Then was the tech director for the Littoral Combat Ship when GD and Austal teamed together. Then ultimately actually was sent by GD to Australia to build the shipyard in Adelaide and develop the air warfare destroyer program over there. I ran that engineering team. And then ultimately retired out of BIW and got recruited into Seaspan, and I've now been here coming up on 8 years actually. Came into the shipyard and took over engineering, and they were in early days trying to size the company and figure out what engineering model they wanted to live by. We then converted the shipyard, I would call it, to more of a vertically integrated engineering capability. So we now have, 7 years later, we went from 20 people in engineering. We now have 300 people in engineering. We're actually I believe, the largest marine engineering firm in Canada now. The NSS has been very good from a engineering development standpoint. We've been able to develop a capability. Goal now is to maintain that and sustain that through the multiple ship programs we have. Our backlog is out to 2040 now. We've got multiple ships in work right now. We just recently delivered the OSV for the Canadian Coast Guard. We're now heavy into our polar build. We've got 2 joint support ships for the Navy, and then the crown jewel, I call it, from an engineering perspective, will be our multi-purpose icebreaker, for which we're under contract for 16 of them ultimately. Under our umbrella contract, the first flight is 6 ships, which is the same flight that became part of the design licensing we did into the U.S. for the ASC program. So we're busy. Team has now grown strong. We've been in place as that team, as a team, for 3 or 4 years now. And now it's all about growing maturity around that team.
Right, so I'm the Research Director at Intelatus Global Partners, a US-based marine and offshore engineering consultancy. I've got over 30 years of corporate and commercial management and strategic planning experience in senior leadership teams and board positions, developing strategy, driving change and exceeding targets in the renewable energy, offshore marine, shipping and heavy engineering space. And that's managing teams historically across Asia, Middle East, East Africa, Europe and the USA. and our interest in icebreakers is we've recently finished a global review and outlook of the polar and subarctic icebreaker fleet.
Okay, well, Phil, I know you have because it's spawned many articles for me across our network, so we appreciate that balance of work and your insight. So, Jim, obviously we're here to talk about the U.S. Coast Guard icebreaker fleet, which we'll do shortly. But before that, I just wanted you to discuss in the round Seaspan's cumulative experience and current order book in the design and construction of icebreakers.
Company was a very small, they were building barges and small vessels locally for years. And as part of NSS in 2010, they were one of the 2 down-selected companies, along with Irving on the East Coast, to begin that NSS process. And as a part of that, our initial contract was for 3 offshore fishing vessels, and those 3 have been delivered. They were ice-capable ships. They were a PC-67 light ice-capable, not a true icebreaker. The hull form was a traditional hull form. We then moved into the 2 JSSs, which are the largest ships ever built here in Canada at 172 meters, but they are not an icebreaker. They are a joint support ship. I call them the coach's box. They do largely C4I capability and then also replenishment services to the Navy. We at the same time had completed the design with Vard Marine for the offshore oceanographic science vessel, which we delivered just at the end of last year. That vessel, as of yesterday, had just gone through the canal. It's headed to the East Coast. It'll be stationed out of Halifax, I think, and or St. John's maybe, and then service up into the Arctic. It is a more capable, ice-capable ship than the OFs, but still not a conventional icebreaker. We then moved into the polar icebreaker contract. Actually, we received the contract for what was formerly known as the MPV, now the MPI. We received that contract first from Canada and then received the polar, but the polar has a more aggressive schedule. It is the ship the Coast Guard wants first, and then we'll move into the MPI. So the polar, we've completed the design for that now. We did that in a teaming arrangement with 2 Finnish partners, with a company called, formerly known as Aker Arctic, now known as Rauma, and a company called Elematic. They represented our Finnish connection. Both had a lot of icebreaker experience. We put a number of our employees over there in a tech transfer setup, basically, so that we had 8 employees who lived in each discipline, learning from the Elematic guys. We've now brought them back here, along with a small contingent from Elematic that's living with us for the build. And then Aker was our hull form developer and did most of our tank testing and did most of our development of the GA and the early hull form. And then we, under license from them, are now completing that vessel. So the design is probably 95% complete right now. We're into production. The ship builds with 180 blocks, 40 of which are now in construction, 4 of which are now on our land level forming a grand block. We'll have a keel laying ceremony later this year. We already meet the 50-ton requirement. Polar icebreakers, as you would know, are very heavy. So the first 3 blocks got us nearly 500 tons, I think, when we joined them on the land level. So we're 10 times past, but The key laying, we don't like to call it a key laying until we can see a full girth of the ship. It makes the ceremony more meaningful than when people call keel laying and there's 2 bits of whatever sitting on the deck. It's not to our standard alcohol.
Yeah.
And then the MPI, we completed the functional design, and functional design by my definition, which is a pretty advanced design last July, and that's what made up the licensing agreement into the U.S. We had actually fully class approved all our drawings, all the down select of the major procurements were done, all the material definition was done, and we had actually advanced the 3D model to a production ready stage, basically. So we are now in that production design phase, which is basically detailing the systems to support drawing extraction and then setting up what we call our pre-production window so that we can execute material by demand and start releasing drawings once we start construction. We could start tomorrow, but because the Polar is coming through our factory ahead of the MPI start, we won't start it actually until next year. That was I said, I think in the SNAME, better lucky than good, because we advanced so early on the MPI and we completed so much of the design ahead of production. It was attractive to the U.S. Coast Guard because they wanted to go fast, and we had a production-ready design sitting in our PLM system, so that became the outcome.
Yeah, Jim, sorry, you just mentioned at the end there that using your PLM system. So, is with the design that you have, is that going to the shop floor as well through connected machines, 3D models, all those sorts of Industry 4.0 techniques and technologies?
Yeah, we are a term I stole from one of my former bosses, but I like to call it digits to steel. We are fully 3D modeled. Our 3D model is integrated to our product lifecycle manager, which is ARIS tool, and we put home in ARIS what we call the bill of material, the engineering bill of material that then planning in a 3D environment plans to every stage of construction. We then load that bill of material along with a drawing package, and we use a tool called eShare, which is a 3D enhanced viewer which allows you to interrogate the model at the shop floor, and we're actually setting up nearly every supervisor in manufacturing now has an iPad. When he's out there with the team and they're installing, he can actually bring the model up, look at his own work order status, look at his material status. It is a fully integrated connectivity so that he's allowed to interrogate the bill of material. He can interrogate his work order status within the MRP system and actually check his status. And if he's having issues with the design paper, he can actually interrogate the model to check dimensions and enable himself to go as quickly as he can.
Okay, that's interesting. And then with the actual dimension control, obviously, as you're talking about the blocks and the block building, are you using point clouds as well to...
We do. We use Total Station, which is
yeah.
our AC tool, and we shoot. In fact, we're shooting today on JSS. We just received the torpedo racks for the JSS from Babcock, and I checked personally last night. Checked. There were several waivers that came in from Babcock on the build out of those. And I told the guys, hey, go to the ship they'd done a great job of identifying everywhere where they were off and told us exactly down to 2 millimeters where they were off on something, but we didn't shoot those in their factory. Let's go shoot them before we install them.
Yeah.
Let's make sure it matches, because sometimes people
That helps
take
the changes.
Yes.
That's important in shipbuilding.
And will that philosophy roll over into the ASC program? Irrespective
that
of
I can't really answer because I'm not building the ASC. So we've given
the
all of the technical information we've now transmitted to the 2 shipbuilders that are working for the Coast Guard in the U.S. That we gave them our full 3D package. We've given them our entire bill of material. Neither one uses our PLM tool, but what we did was we actually extracted the data out of the PLM tool and built a series of flat files so that they could then bulk load into their PLM tool the same, when you look at the bill of material for a valve and the attribution that goes with it, we have 54 fields of attribution. We went through that with the 2 shipbuilders and said, do you want all the attributes I use? We cored that down somewhat because a lot of our attribution is for our own shipyard, every compartment detail, every system detail. We put some of the manufacturing background information in as an attribute. We cored that down, built the flat file. We did the full transmittal once they were under contract right after Christmas. They are in the process now of digesting what was 47,000 pieces of technical information so they can begin their job.
That's awesome.
I think it'll
that's
go
a
well.
big amount.
It's a good head start, is what I tell everybody.
Just hearing that exhaustive backstory, it proves beyond a shadow of a doubt why I write about it and don't do it. So, so Phil, I wanted to get from you. I wanted to get, before we dive into the Coast Guard project, I really wanted to get kind of an overview of the icebreaker market globally as you see it, because I know you and your team at Intelatus recently completed an exhaustive report on the global icebreaker fleet. So, I know it's way too long to summarize in a short segment. Can you give us highlights of the report? Who dominates the world icebreakers in terms of design, construction, owning and operating? And, I know the answer, but where does the U.S. rank in this regard?
Well, I mean, the report focuses on polar class, or the equivalents of polar class icebreakers, and the subarctic icebreakers built to Finnish, Swedish icebreaker rules or equivalent. So we're not looking at polar class C. These are polar class AB vessels, and that's Russia, Canada, Finland, USA are the largest owners of in-service and under construction planned icebreakers, accounting respectively for around 70% of the active and 92% of the on order or planned under construction. There's a lot of stuff that's on order that hasn't yet met construction. For instance, as Jim's mentioned with the Canadian NSS program, with the medium icebreakers, you've got the 3 flights. I think it's 6, 6, and 5, if I'm not mistaken. And flight 1 is confirmed, but then there's budgets, procurement for the second flight, third flight. Same with the US icebreakers. You've got 1 polar class icebreaker, budget approved. There are 2 more planned, committed in theory, but they also need budget approval to actually go through the engineering, procurement, and construction. The US accounts for under 10% of the global active fleet. With its polar and Arctic security cutter programs, that's accounting for around 20% of the under construction and on order new icebreakers. So there's a significant amount done there. Obviously, the NSS program in Canada is pretty much one of the biggest programs around. Although the Russians, through their nuclear icebreaker program and their conventional program, are still churning out quite a lot of icebreakers. Traditionally, they used to use Finland for that. Now they've gone domestic, obviously, with the sanctions that are in place. Now, drivers for fleet renewal are aging North American, Baltic and Russian fleets. You've got some very old kit out there. The Finns have got a 1953 icebreaker, and the Swedes and Finns have got, old 50s, 60s icebreakers that need replacing. So they've got to do those fairly soon. You've got the growth of the Asia Pacific and South American fleets, so one or two in places like Chile, Argentina, Australia, South America, South Africa, but also obviously Japan, South Korea, and mainly China. And there's increased security and territorial management concerns. Exploiting the three Arctic shipping routes is a big driver. You've got the Northwest Passage on Canada that's still got relatively limited commercial traffic. The North Sea route, which is really around Russia to Asia, which is getting increasing traffic. That's driving nuclear icebreaker building and a new generation of conventional Russian icebreakers that have been announced at the end of last year for their ports. And the transpolar route, which is right through the middle of the Arctic, which is where the Chinese are interested, and that's big nuclear icebreakers and possibly very large conventional icebreakers. You've got oil and gas and mineral exploitation. That's generally in sort of Russia and going around the east towards Asia, but also the Arctic is proving to be of great interest to a lot of people for rare earth minerals, oil and gas. You've got the Antarctic and Arctic research and tourism. So there's all these things together that are driving a growth of under construction and planned on order vessels of probably 70 polar class or subarctic equivalents to polar class 6 and 7 icebreakers. So that's a substantial market. And when you get to the very heavy icebreakers, these are very expensive capital expenditures, $1 billion plus. The medium icebreakers, sort of in the 100 to 700, several $100 million. These are big pieces of kit, and obviously they feed a whole supply chain, and they're real supply chain opportunities, and we try to cover that within the report. So that's a sort of high level pitch of what we address.
Seaspan Shipyards is a leader in Canada's ship design, engineering, building, and ship repair industry. With modern facilities and a dedicated workforce of about 5,300 in North Vancouver and Victoria, the company is a trusted and strategic partner on a range of complex projects for both government and the private sector.
That's awesome, Phil. And again, I very much appreciate it. So now let's get to the meat of the discussion. Of course, that's the U.S. Coast Guard icebreaker. So, Jim, as I understand it, Seaspan Railotech is supplying its MPI design along with project management services to both Bollinger and Rauma Marine Construction for the USCG Arctic Security Cutter program. Rauma is due to deliver 2 vessels in 2028, Bollinger the first 4 in 2029. Can you put some more meat on the bones of the project from your perspective with insights on where are we in the process today? And also, does this agreement include procurement for the U.S. ASCs?
Answering the procurement question, we supplied as part of the deliverable for the license, we supplied we had completed all the technical procurements for all the significant equipment. It was right around 100 technical procurement specifications. We actually got approval from all of our suppliers to give the vendor furnished information that matched the 3D design basically that we had completed, so they'd have a head start. We offered against both programs, because we don't know Flight 1 to Flight 2 whether Canada is going to significantly change the design of the ship yet. They haven't yet come through with what they view as the Flight 2. We know there'll be some sort of an upgrade, potentially significant, but from a mitigation standpoint, when we got under procurement for all of our procurements, we actually developed them with the procurement of the first 6 and then options out to 16. So we had existing options. We did offer to both shipyards. We could execute the options for you and get you moving a lot faster. They've chosen to renegotiate. So they've taken the technical information. They're now out with our suppliers, and in some cases, potentially recompeting some of those supplies to within their own supply chain. Some of them that clearly will stick with the engine selection, and they're out renegotiating with Steerprop and Wärtsilä on those projects. But other procurements, like we buy under a technical procurement spec all the doors for the ship. We did that with a company in Europe. We knew all along doors are pretty standard. You can probably recompete those without introducing too much complexity from a design integration standpoint and still move quickly. So they've chosen to do their own procurement for both the Bollinger ships and the Rauma ships. We'll support them. We have what we call a support services contract with them, which is basically we have single person in Finland who's in their time zone who can both answer questions quickly, if they have struggling with one of the design details and reach back to our engineers, we'll make them available with a plan to turn questions around in 24 hours. That services contract, depending on what they want, could grow. My recommendation to both shipyards, every shipyard's different, and when you do that production detailing to your drawings, it's very specific to your build methodology and your details. I actually told them, I don't think you want me doing that for you. You want to do that for yourself, but we'll support you in any way we need to make sure you don't get hung up on something without an answer. So we had a question this morning, in fact, around our bow thruster sizing of the tunnel. We gave them the supporting detail on why it is exactly the size it is, based on the operational profile of the ship, because this was a recommendation from both the supplier and ACCR. Our bow thrusters don't have grates on them, because when you are actually in the Arctic, you're better off to design the bow thruster to chew the ice, and it is ice-hardened bow thruster. If you put grates on them, they tend to pack in like a snow cone, and you can actually lose performance. So they were nervous about the size of the tunnel. Was it sized appropriately for the ship? And it is. We gave them all the information this morning. They were comfortable, back to work. And so it's working well, in my opinion. I can't speak for where they are in procurement. I can't speak for the status of their construction. I do know they both intend to start this year, but we're not privy to the negotiation that's going on between them and the Coast Guard. I know they're both under an initial ancillary sort of contract with negotiations going on for the final bill pricing for all of the vessels. But their initial contract allows them like 180 days of operations, including all the long lead material and getting things going. Then they'll finalize their final build schedule and numbers, I think, over the next couple months.
Can I just ask with
go ahead, Phil.
that?
Go ahead.
Obviously, one of the attractions of the ASC program was buying off-the-shelf designs, and with US military procurement in particular, and Coast Guard procurement, we've heard over the years of yes, we need to go off the shelf to try to speed things up, but obviously we've had cancellations of contracts recently which were off-the-shelf designs because the percentage of change was more than 50% from the client. Are you seeing with the US Coast Guard requirements, ARC requirements coming back to you, asking for significant changes to the design, or is it really
I do know
going
the
to be
two
off
companies.
the shelf?
I do know they're having conversations with the Coast Guard about potential changes. But the Coast Guard, when they were here with both Rauma and Bollinger last fall, it was highly committed to not changing. And they had, I believe, I'm going to say you can count them on one hand, things they wanted to consider. And I think they have come through that now with both companies. And I think the Coast Guard did two very bright things. One was they only did the things that could easily be done in line with the build. And then for the ones that couldn't, I do know they said we will look at them as a post-delivery sort of backfit, you know. The one area that would be obvious to you is from a C4I or a C5I now with cyber. Every government operates slightly different in what they want from an air search radar, what they might want for comm systems. They evaluated the design. It closely met their needs, and they said, I think if we have to change, we will look at that as post-delivery, because speed to delivery is the most important thing for them right now. So I applaud them for taking the right attitude. Actually,
that's refreshing. That's refreshing to hear, given that some of the problems with the procurement over the last few years and military and Coast Guard programs.
What are the roles of Railitech and Seaspan in all the Canadian Polar and MPI and the U.S. ASC programs?
Yeah, I can speak for my role. So Polar, we are the prime into Canada for the Polar Icebreaker we are building, and Railitech is one of our named subcontractors. They did the hull form development with us. The original Polar design, you may know, was a long time in the making. With the two Coast Guards, they both were building off what was called the Diefenbaker design for years and years and years. The U.S. ended up, I'll say, taking an off-ramp and looking at a German design that they ultimately took into the PSC contract. We received the, I'll call it, Diefenbaker concept design or basic design out of the Coast Guard, along with their requirements. And when we got started in 2021 with ACR's support, or Railitech support, we did a basic design evaluation against the requirements, and then we optimized the platform. So it ended up, I would say, becoming a different ship than the original one that was born from the Diefenbaker. That was all done in the basic design process. We lengthened the ship. It was, because it was, the Diefenbaker design's been around for, I'm going to say, more than 20 years. And it actually didn't accommodate the now helicopter that the Canadians are operating. So we had to extend the flight deck, which resulted in about an 8-meter lengthening of the ship, and then we optimized the hull form for both. Railitech is really good at optimizing between open water and ice-going performance and coming up with the right optimized hull. The Diefenbaker, in fact, had a knuckle-shaped hull. We've actually gone with a more conventional, uniform hull as a part of that whole optimization. So they'll be with us in a very small role on our Polar. On MPI, as I said, what we just talked about, we're basically have released a licensing deal, and we're here for support services as required. I don't know what Railitech's, they are sub-licensed to us in the licensing deal because they own the IP on the hull form for the MPI, but they are part of the group of 4 companies that work together on this ASC, and because they are local to Finland, I suspect they will have a more significant role in the Rauma, execution. But I don't know any of the details about that.
Yeah, we'll get them on the next one for sure.
There
So
you go.
So Jim, the next question, because it was asking about that off-the-shelf design, clients making changes. Do you
I
think
mean, the
that's
other thing
sufficiently?
I would stress, it's your definition of COTS. COTS for me, we define it in two groups. We have non-COTS and we have COTS. Non-COTS is anything that's bought under a technical procurement spec unique to that platform, like the engines. The engines on the Polar are very different than the engines on the MPI. So against those 100 procurements that are in that non-COTS, we have about 40% actually standardization to the MPI. We made a concerted effort in the electronics, for example, when we were selecting our comms package under the LLI contract, the non-COTS contract for Polar. We specifically looked at the opportunity to roll those elements to MPI. So we got about 40% commonality between the two programs on what would be designed for specific to the ships. And then into the COTS side, which is, valves, fasteners, standards, flanges, all of the other things that build the ship. Against the COTS, we're actually 90% common between our two platforms. So we have standardized, and I believe the Coast Guard will be very happy with the outcome, because when you standardize at that valve level, when they're doing maintenance over the 40, 50 years life of these vessels, knowing they have the same bronze, same fitted, same flange dimension, both on their Polar and their MPI, and hopefully transmitting into the Coast Guard, U.S. Coast Guard vessels, I think interoperability and supportability between the two countries has a real possible win, because that, to your point, if you maintain that common off the shelf, it's during maintenance where you get the biggest benefit.
Absolutely, absolutely. That's excellent. And again, thank you very much for the insight. So, we're winding down here. I just have two more questions, really. So, Jim, obviously, per your introduction, you're a long tenured maritime executive with lots of shipbuilding, ship design, and construction projects under your belt. What do you see as the primary challenges to this project? And when I say this project, I'm talking about the U.S. Coast Guard Icebreaker project from an engineering point of view.
All projects live and die by what you brought up earlier, which is change. If we control our appetite and we manage change smartly, these programs will go very well, because the maturity of the design we handed over was at a very high level. I was trained by a guy by the name of Fred Harris, who recently passed away, but Fred was a lifelong shipbuilder and my boss for 4 years at Bath, and he had a mantra: you finish the design, you finish the plan, and then you build. And that's what we are doing on both these programs. And what we pushed into the U.S. as part of the license is a finished design. So if they stick with that design and don't change it, I think they're going to go well. I think if your worry becomes real and they wring their hands and what I call the Ivans come out of the woodwork and say, I have another good idea, that will, they're better off, getting ships into the fleet, looking at future flights and looking at changes once they're in service. That way the numbers will grow, and I think once they're running the ships, they'll be very happy. The Arleigh Burke program, the one I cut my teeth on, they're up to 73 ships in the fleet now. The Arleigh Burke, I was the flight upgrade manager for almost 10 years. We were able to do upgrades, slight knuckle up in the cost on the upgrade ship, and then back down the learning curve. And those ships have gone out of Ingalls and Bath for the last 40 years consistently at good value. And for me, if the ice breaking approach could follow that kind of an approach, I think the numbers will go way up. And I would love to see the U.S. Coast Guard get happy with the first 6 and or the 5 that are coming from Davie and say, okay, let's keep pumping them out, because that's where the goodness comes from.
That's fantastic. I can't say that I knew Fred Harris personally well, but when he was at NASCO, I visited with him several times and was able to sit in his office and interview him. And you talk about a font of information. Absolutely amazing man.
Yeah. I will say that you'll probably have to cut this out. He's the only man I'm a big guy. I lived my career by saying I have more ass than most people have teeth. And when Fred came to be our boss at Bath in 2013, I was running planning at the time at Bath, and he came into one of our breakfast clubs and planning was under the microscope, and he chewed on me for 45 minutes, almost our first engagement. And I walked out, and one of our hull managers looked at me and goes, "How'd that feel?" I said, "I've lived by the principle that I have more ass than most people have teeth. I think I just met my match, man." that man, we became really close, actually, over the 3 or 4 years I worked for him, but he let you know where you stood, which was good.
Gentlemen, I genuinely appreciate your time.
Right.
I really do. This has been instructive. It's been absolutely entertaining. Just one final question, and how do you see icebreaker demand evolving in the 2 to 5 years, based on your insights into the market?
I'm not sure I can answer that from
who
has demand. Phil is probably better positioned for that.
Excellent.
No, thanks, Jim. So, as we noted earlier, the drivers for fleet renewal are aging North American, Baltic, Russian fleets, the growth of the Asia Pacific and South American fleets, the increased security and territorial management concerns, exploiting those 3 Arctic shipping routes, and oil and gas, mineral exploration and production, Antarctic and Arctic research and tourism. So the US and Canada, they're both building these new medium and heavy polar icebreakers and completing refits and life extensions to their existing fleets. So that with the NSS program and the Coast Guard budgets prior and current in the US, there's a lot of work ongoing at the moment that's going to keep that supply chain pretty busy for quite a few years. And certainly in Canada, the NSS program has been keeping those shipyards and suppliers pretty busy for quite some time. Not just the new building yards, but as I said, the refit and life extension yards, and obviously Seaspan have been involved in that as well. But once US and Canada is finished with their fleets, that work's going to be completed in the 30s. There's a lot of work. What comes next is the big question, as Jim mentioned. It's whether they want to go for the volume and keep on building these program icebreakers, or, are they going to say, well, we've built what we need, let's sit down on these for 30 years, 50 years, and then come back in 50 years' time to build more. Too early to say at the moment on that. But it's unclear if those new vessels will be built. Finland, Sweden, they certainly operate an aging core icebreaker fleet, and that really needs replacing. And they've got a common design for Sweden and Finland. They've gone out. Swedes have placed the first vessel, although there are objections for that because it was intended to be built in the Baltics, but the Korean shipyard was the low bidder on that project. But there should be several icebreakers to be built there, and they're between the Baltic sort of A and B class icebreakers. Russia has a large new building program, both replacing existing aging icebreakers and support the expansion of the North Sea shipping route. That's nuclear icebreakers for escorting and conventional for ports. And I think with an eventual peace with Ukraine, we've all got to hope that conflict ends, that should open up the Russian market once again for overseas suppliers. It was really Finland's big sort of engine for icebreaker design, construction and supply chain, but that's really been cut off with the sanctions. But also with the if Russia opens up, I think you'll see a bigger exploitation of the North Sea route. The Russians are certainly looking to have 365 operations in that, and that's why they're going heavier with the nuclear icebreakers and into very heavy conventional icebreakers, which they've got their new program was recently announced. But you've got China, Japan and South Korea have all expressed real interest in using that North Sea route, and also for shipping, but also getting into the oil, gas and exploration up there. So that'll drag them into the Arctic as well, because quite a bit of that North Sea route is in the Arctic. And finally, you've got the Antarctic, where there's certainly been increased research, supply and territorial security activities, and that also includes new icebreaker construction. At the moment, the next one will probably be in South America when they pull the trigger in Argentina. So there's quite a lot of those sort of A and B class, those polar class 1 through 7 icebreakers that probably presents that opportunity, as I mentioned earlier, of around about 70, 80 icebreakers at the moment. They're either already committed under construction or on order, planned to be built as part of flights or future plans. We see that getting added to. Beneath that level, that sort of C-class icebreakers, you've got the ships, obviously, but you've got the anchor handlers and the sort of port tugs that secondary or emergency function is icebreaking, but their primary function is something else. And there are still aging fleets of those out there as well, and there'll probably be some building of those. As climate change continues and more sea ice sort of flows into shipping channels and ports and areas. Although the Baltic this last season had a particularly cold season, to the extent that they actually brought the first nuclear icebreaker into the Baltic, Russia's Sibir. The ice conditions were that heavy. So we could be seeing fluctuations that change one day from breaking ice to one day very, very thick ice, requiring sort of these sort of heavier icebreakers still.
That's awesome, Phil. And again, thanks for bringing that home. And actually, far from the icebreaking scene, but I live on Long Island. I have the Great South Bay. We have a depth of maybe 10 to 12 feet. It gets a little deeper, but for the first time in about 15 years, we actually had the ice sailboats, the ice boats out. And
wow.
That's a sight to see. That's absolutely amazing.
Yeah.
Cool.
So, gentlemen, gentlemen, I sincere thanks to both of you. You both have done above and beyond Call of Duty. I know everyone's busy. I appreciate your time, and I thank you for visiting Maritime Matters.
All right. Thank you.
Thanks very much.
Nice to meet you, Phil.
Nice to meet you,
All right,
Joe.
I'm gonna hit.
Thank you for listening to Maritime Matters. If you would like to be featured on a future Maritime Matters podcast, visit www.marinelink.com or email maritimematters@marinelink.com.